By the end of this lesson, you will be able to use the sinusoidal functions to solve real-life problems. So for example, the temperature in the summer will be hot. When we reach the winter, it will be cold, hot, cold, hot, cold, and this pattern will keep going in the same manner. Let's have a second question. If the summer in the UAE started in June this year, when would it start next year? Do you think in June? What about the year after that and the year after that? It will keep starting in June every year. That is correct. Now, what comes after the summer? We know that after the summer comes the autumn or the fall. Is this always the case or does it change? Of course, this is what happens always. So these are some examples of periodic things that happen in our daily lives that we can relate to the sine and cosine functions, as we will see in the following examples. An example of that is the average temperatures in Dubai. We can see that we have the average temperatures here for each month throughout the year in Dubai. And if we look at the temperatures, we can see that they are increasing here until they reach the highest value, then they will start to decrease. And after December, we will go back to January, where the values will increase, then decrease, and so on. So we can expect this to be a sine or a cosine function when we graph it. First, let's change the names of the months. Instead of having names, let's have numbers so that we can graph them or plot them. Your task now is to use GeoGebra or any other graphing technology you prefer, like a graphing calculator, Desmos, anything you prefer, Excel maybe, to graph these points. Okay, let's take a look at the result. If you did it on GeoGebra, your screen should look like this. And it is very easy to plot points on GeoGebra. If you don't know how to do this, just go to GeoGebra. And on the space here where you can type, just type a bracket, 1,24, close the bracket, and hit enter. And A equals will show up automatically, and the point here will be called A. You can repeat this for the whole 12 months. As we can see, it is increasing, then decreasing. So this is a periodic function that we can represent with a sine or a cosine. Now, in order to be able to model this data as a sine or a cosine function, we need two very important values. These are the maximum and the minimum values. Please note that the maximum and minimum values are taken from the y variable, the y list, so from the temperature here. So we find the maximum or the highest value in the temperature. If we look carefully, we will find that the maximum value is 41. So this is the highest or the maximum value. We denote it with capital M letter. So M capital equals 41. This is the maximum. And the minimum value is the lowest value, which is 24 here. So the minimum M small is 24. Some students will think that they can take the maximum and the minimum from the X value. So they will take the minimum as 1, the maximum as 12. This is not correct. We always go to the Y variable, which is the temperature here, and take the maximum and minimum value. Then we need to choose which function are we going to use. Are we going to use the sine or the cosine? We can use both. Both are okay. In your book, you have an example of using a cosine function to model. Here, we will use a sine function so that you know how to model using both functions. Remember that the sine function is represented as y equals a, sine bx plus c plus d. Our job is to find these four constants, a, b, c, and d. Now, remember that a is the amplitude. And if we look at any sine or a cosine function, we know that from the maximum to the minimum, there are two amplitudes, because the amplitude is from the midline to the maximum or the minimum. So from the maximum to the minimum, we have two amplitudes. So in order to find one of them, it will be half the maximum minus the minimum. One amplitude, A, is half the maximum minus the minimum, 41 minus 24, which is 8.5. So A is found this way, which is pretty easy. Let's find D, which is the midline. The midline is always in the middle between the maximum and the minimum. For example, here we have the minimum 0, the maximum 2. In the middle between 0 and 2, there is the 1. How to find this, how to calculate this for other numbers? We add 0 plus 2 and multiply it by a half. So the D, or the midline, is half m plus m, which is here 32.5 in this example. So A and D are easy. Let's go to a one that is more difficult, which is finding B. Remember that B is related to the period. So let's first find the period, because we can do that. The period is equal to 2x maximum minus x minimum. What do we mean by x maximum and x minimum? We know that the maximum is 41, so the x related to this maximum is called x maximum, 7 here. And x minimum would be 1. So 2 multiplied by 7 minus 1 equals 12. This is the period, and we can expect it to be 12 because every 12 months the function will repeat itself. The summer, winter, all the seasons will be repeating themselves every 12 months, so it was expected to be 12. Now, after we find the period, remember that the period equals 2 pi over the absolute value of b. So we have the period, which is 12, equals 2 pi over b. We can do a cross product and find the value of b. It will be pi over 6. So now we found A, B, and D. We are left with C and C only. This is the most difficult part, but it still can be found easily with more practice. So you need to practice more on finding the value of C. Remember that C is related to the phase shift. And we know that for a sine function, it starts from 0, 0, and after the whole period, we will reach 0 again. So the maximum happens where? It actually, in the sine function, happens not at half the period, it happens at quarter of that period. So from here to here is the whole period. This is half the period. The maximum happens at quarter of that period. So quarter of the period is the original maximum. So the phase shift in our data is, because the period is 12, 1/4 of the period, 1/4 of the period, which is 12, this is equal to 3. And the maximum is happening at 7, so there is a phase shift for the maximum. From 3, it should be at 3 here, but it is happening at 7. We can see that. So the phase shift will be 7 minus 3 equals 4. Now, when we find the phase shift, we know that the phase shift is equal to minus c over b. So 4 equals minus c over pi over 6. We already found b. Again, cross product, you will find that c equals 4 multiplied by minus pi over 6, or like this, which is minus 2 pi over 3. Now we found everything that we need, so the equation will be y, a equals a sine bx plus c plus d. A is 8.5, d is 32.5, so this is d, the last one. B is pi over 6, and c here is minus 2 pi over 3. So this is our model. This is our function. Now, if you go to GeoGebra and on the same plot try to graph your function, the one that we've just found here, y equals 8.5 sine pi over 6x minus 2 pi over 3 plus 32.5, you will see how the graph that we just did is very close to the data that we have at the beginning. We have some months out of the graph, but that is okay, as we have learned in modeling with nonlinear regressions in the previous chapter.
Now, before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
Now, what if we wanted to model with a cosine function? The good news is there is not much differences between the sine and the cosine. For finding D and B, it will be the same for sine or a cosine. The only difference will be in finding C. So in order to find C, the phase shift in this case will not be 7 minus 3 because the cosine has a maximum at 0. So the phase shift, instead of being 7 minus 3, it will be 7 minus 0 because the cosine function has a maximum value at 0. So the phase shift will be 7, which means this equation is still valid, but now we have the phase shift not 4, but 7, and C will equal minus pi over 6 multiplied by 7, not 4. So the C value will change to minus 7 pi over 6. The same function, just with a cosine this time. All the values are the same except for C. We can see that C is now minus 7 pi over 6. Now, which one is better, this one or the previous one? Actually, both are exactly the same. So your task now is to graph the cosine function from the previous slide and compare it with the sine function that we found before. So go to GeoGebra and graph both functions. You can pause the video now and come back after you finish. Well, hopefully you found out that both the sine and cosine functions are exactly the same. Here I have graphed both the sine and the cosine functions, and on GeoGebra they are exactly the same. I can see only one line because it's exactly on top of each other. So we've done task 1. Now task 2 for you is to find, based on your model, what would be the temperature on mid-April. So in April, what would be the temperature based on your model, the sine or the cosine model? Of course, it should be close to 33, but we want to see if our model predicts the values in a close way to the original data or not. So please pause the video, find that, and come back when you finish. So I will use the cosine function. Both are the same. Cosine or sine, they will both give you the same answer. Here I'm using the cosine one. And instead of x, I will substitute the value of 4 because we are talking about April. And in April, this is the 4th month. So I'm using x equals 4. And if you substitute the values, use a calculator, you will find that y equals 32.5. So the temperature will be 32.5, which is very close to 33. So our model predicts the values very well. We have a good correlation coefficient, even if we don't have to calculate it